Hello, everybody. Happy Tuesday. It's Tuesday today. Rustle Bus Day 2. Yesterday we did a lot. Today we're going to do some more. Yeah. I think we should probably just switch straight over to this screen and talk about where we were. So, we took this educative course that has like 124 lessons, 52 quizzes, 20 challenges, blah, blah, blah. Bunch of images, all sorts of cool stuff. And my mic is very loose. I've been doing a lot of videos today. Yeah, there we go. So we're going to continue learning. We did like 17% yesterday. It was pretty good. I had a good time. And yeah, let's see where we get. Let me know if the levels are a bit too high. They should be okay. Let me just monitor. Yep, they sound fine. Okay, cool. Let's continue learning. Also, I'm wearing this Next.js hat because my hair is terrible. And it's nice. And it's free. Okay, constant variables. Constant variables are ones that are declared constant throughout the program scope, meaning their value cannot be modified. They're defined in global and local scopes. Just spilt Ghost energy drink everywhere. Lovely. They're declared using the const keyword followed by the name of the variable, colon, and then the data type of the variable. Okay, makes sense. By convention, you write a constant variable name in screaming snake case, aka uppercase. I always forget it's called that. But all letters should be uppercase, all words should be separated with an underscore. The following example defines two constant variables, ID1 and ID2. ID1 is in global scope, ID2 is in a local scope. And when we print these, they print the numbers. The differences between const and let. Constant variables are declared using const keyword, unlike let variables. I feel like this is a bit like Captain Obvious. Like, yes, let and const are definitely different due to the fact that you declare one with a const and one with a let. But I also understand like the reasoning behind it. I imagine they like really want to make it as easy as possible. Yeah. Okay. Const variables are declared in global and local scope, unlike let variables that are declared only in the local scope. Consts cannot be mutable, unlike lets. Data types, unlike let variables, it is mandatory to define the data type of const variables. That's good to know, I guess. The value of const variables can only be set before running the program, whereas let variables can be stored. Let me read that again. Let can be variable can store the result at runtime. Okay. Unlike let variables, const variables cannot be shadowed. Cool. I've literally forgotten everything from yesterday. So that's good. Just have to go back and read. Okay. It's just the regular arrays. All right. So we can just do... do we need to call it anything? Write your code below. Oh, okay. Hold on. Okay. Array equals 0 to 8 and 10. And then there's like this... Use the subscript notation this for accessing the arrays of an array. Do not debug tree. So you want me to do like a print? Like this? and then do this. This is not right. Printing is so weird. I know this is not right, but I'm just going to keep typing it because it makes me feel better. All right, let's go back to arrays and look at how we print them. Oh, I can do it like that. Yo, I'm smart. It has been a whole day and I've forgotten, but you can do it like that. I knew what I was doing. I was just testing everybody in chat. That's fine. All right, so we can just say array equals 0, 2, 4, 6, 8, 10. Then we can do print. And then we can copy this. Do this. 1, 2, 3, 4, 5, 6. And then this feels really this feels completely like we shouldn't be doing it this way, but we'll just go with it. 1, 2, 3, 4, 5. Is this how you do it? I guess it could be worse, right? I mean, I'll test it and see what happens. Oh god. This old classic. Semicolons. My linter does everything for me. Okay. I guess you probably can just put commas here because I'm dumb. And I should know better, and I just should have assumed. Also, this interactive thing is not great. It does have some flaws. Like, okay. 1, 2, 3, 4, 5, 6. Yeah, okay, James. You know how many things are in an array, right? Starts at 0, ends at 6. All right, cool. I am smarter than I feel. Okay. I've solved it, but I feel like there was an easier way to do that. And like, nope, okay, that's what they wanted you to do. Although they defined the actual length and bits, which is quite surprising. I would be amassed to say that that's surprising. Is my bitrate good? Yeah, my bitrate's fine. I've been a bit concerned about bitrate lately because, or at least stream health in general, because I have like the worst internet ever for streaming. When I moved to this new house, like our internet, my stream just fucking terrible. But good, we got that right. Okay, we could have declared the actual, like we could have just declared what we wanted, but okay. So I remember this from yesterday is that you could do, like, you have to declare the variable type. You have to declare that there's going to be a type of this and a type of that. But let me go back and check, because this was like getting to the point where, or maybe not. Maybe you just go for it then. Without, okay, you don't have to specify type if you don't want to. Okay. So it would be let persons equals Alex, comma 21, comma Abe, comma 22, comma Anna 23. Gotta go back now. Feel like my brain just like let go of all the important stuff. And like everything else is just gone. Which seems fine, I guess, at this point. Let it go. Just let it all go out of your brain. Okay. I did that, and then this, comma, this, comma, this. Okay. I did that. And then it's just index value, right? So you could do this. And then you could just print those, or you could do it this way. But it makes more sense to do this. And then just print them, in my opinion. So let's do that. Okay, so now I have to rewrite everything because it doesn't hold the data. So let people, persons equals string Alex, comma 21, comma Abe. Why do I think there's something about numbers here that I'm forgetting? 22, Anna, 23. Okay, then we can do like let, and then like A, B, C, D, E, F equals persons. And then we can do print. And then it would be this. Wait. This colon that comma, this colon that comma, and then this colon that. That looks the same, and then it would just be like A, comma, B, comma, C, D, E, and F. 1, 2, 3, 4, 5, 6. Is that right? Oh, there's probably like semicolon missing here. We'll throw one in there. We'll throw a space in here just for posterity. Expected a comma. Oh, should there be a comma at the beginning? I just wrote a print statement like 2 seconds ago. All right, cool. There we go. So that was fairly easy. It wasn't the easiest thing I've ever done, but let's go through the solution here. On line 3, a tuple, tuple, depends on who you want to be. Tuple for me. And then they printed it out person 0, 1, 2, 3, 4. But I did the other version. Now that you've learned about data types, let's move on and learn how to perform operations in the next chapter's operators. Oh, operators. Here we are. Here we are. We've done it. Let's just put this here. There we go. An operator is a symbol that takes one or more values and outputs another. It tells the compiler to perform some sort of operation. The operators act upon a single operand or unary operators. We got things like borrow expression, deference expression, negation expression, logical negation expression. So borrow, defer, negate. Then we have the binary ones, which are like arithmetic, logical, comparison assignment, compound assignment, bitwise, and typecast. Interviewing soon? Nope. Definitely not for Rust, I can tell you that for sure. Okay. Yep. I'll run this, but we all know addition, modulus, etc. So modulus has a remainder of 1. Yeah. What is the output of the following code? Okay. A equals A plus B. Okay, so that's 12. No. It's then 1. What is happening here? So this is 7, then 12, and then 1. So that's 19, 18. So the answer is either going to be 18 or 18 negative 15. And then B equals B, which is 3 minus A. And A is negative 15. Math. That was a really shitty example of math usage. No offense to them, but like having somebody be like, "Hey, can you figure out this?" And then like nobody can figure it out. Am I also live on YouTube, or am I just pretending I'm live on YouTube? I like to do that a lot. No, I am live. Okay. Cool. All right, let's move on. In the next lesson, you'll learn about logical operators in Rust. I can do logical. Logical operators are true false values. This is an and this is an or statement. And this is a negative. So this says and, this says or, and this one says not. The logical and or are also known as lazy Boolean expressions because the left-hand side operand of the operator is first evaluated. If it's false, then there's no need to evaluate the right-hand side. And if it's true, there's no need to evaluate the right-hand side. In the case of an or. Okay. The following example shows logical operators. Okay, so this is true, this is false. So this would just print out true, false. This would say false, true, false. Yeah, false, true, false. Oh, we're just going to do these like random random versions of like doing stuff, which is always fun. Okay, so A and B equal false. A then equals if A and B equal each other, which they don't, or A is or not A. Okay. And then B is not B, which is not true, which is true. So it's going to be like false, true. Wait. Or A is. Yeah, so that would be true. Oh, I don't know anymore. Oh, no, I had it right. Yeah, true, false. I'm dumb. Can't always do logical in my brain after doing 8 hours of other stuff. Okay. What? How's my hair look now? It's fine. I can take my hat off now. All right. What are comparison operators? We have less than, greater than or equal to, less than or equal to, equals or not equals. Okay. This is the same as everywhere else. So this is true. So, wait, what? Okay. I imagine that's like false, and then false. Because A is not greater than B, and B is not less than A. So that would be false. And then B would be the opposite, not B, which is false. See, I can do logical operators in my head sometimes when they're really basic ones that I don't have to think about. That's how that works. Okay, bitwise. Bitwise operators deal with binary representation of operands. Okay. So that's and, or... excuse me? Excuse me? What does that mean? Oh. Bitwise or operand 1 and 2. Okay. And then left shift to move all the bits in operand 1 to the left by the number of places specified in operand 2. New bits are filled in with zeros. Exclusive or... I'm also on Twitch. I always stream on Twitch because, like, technically I am an affiliate on Twitch. So now it shows the bitwise and or X or left shift and right shift. Okay. Operand 1 and operand 2. Bitwise, okay. 51011110. 100 is greater than 4. Okay. Well, this one's fucking confusing. All right. And then, okay, so A ampersand B. Yo, bitwise is weird. Okay. B equals, okay, so B is probably going to equal 2. And I think this is 0. I'm going with that. Oh, I am completely wrong. Okay. Well, wait. Okay. 1 and 2. All right. So A ampersand B would be... Okay. And then 1 to the left would be 0. Okay. And then the to the left, 0. Okay, that makes more sense. I apparently don't know what I'm doing. All right, cool. And then the assignment and compound assignment operators. These lessons teach assignment and compound assignment in Rust. Assignment operator uses to save a value in the variable. Operand equals this, assign the value. A equals 1, B equals A. That means 1. This would be 2. And then this would also be 2. There we go. And then we just got this stuff. The compound assignment is used to perform an operation, then assign the value to the operand. Oh, this is like plus equals is add and assign the value. Add the left side to the right side and then save the updated value on the left-hand side. Subtract, divide, modulus, bitwise, shift left, and assign. Okay. Yeah. Okay. Let's see here. So A plus A equals 4. B minus 3 is 0. This is 4. This is 0. This is 3. 3 and 0. Math is easy. Math part, totally get that. I don't hate this. Rust is not bad. I mean, on a scale of 1 to 0, it's a 1. On a scale of 1 to 10, like, it hasn't been that bad. In comparison to other languages I've learned over the last decade, like, I certainly can't complain. And, like, some of the stuff totally makes sense, and some of the, like, typing is cool. I think I'd like to build just one thing with it at one point, just to see, like, how quickly I could build something. Well, once I'm done, like, doing Rust or Bust, it would be good. Okay, so we're typecasting now, which is always fun. You have basically not reached any significant Rust features. I am well aware of that. But also, like, all these none of this is like anything that I haven't written like 1,100 times before in my career. But my point is more that, like, there are things that have come up in other parts of this that make sense from a typecasting, like typecasting or like typing and things that I use every day in my regular job as a Typescript developer. So, like, I'm well aware that none of this is like anything that's a significant Rust feature and is just basic programming. Anyway, so this could be just thrown in as float 64 and then divided by 2. Integers can be casted to float point and vice versa. Integers can be typed as string, which is just basic stuff. String, our character cannot be typecasted data type of type integer or float, which is obviously for reasons. Character cannot be typecasted to string type or vice versa. Trying to set this A to a string will give you an error. Cool. Okay, so A as that, 1/3 would give you this. Cool. Borrowing and dereferencing operators. References are just like pointers in C. Well, I've never written C in my life. Two variables are involved in borrowing. Relationships with the reference variable holds the value that reference variable borrows. The referencing variable simply points to the memory location of a referenced variable. The following illustration shows operand 1 borrowing the value of operand 2 using two type operators. Okay. There are two types. Shared borrowing. A piece of data is shared by a single or multiple variables but cannot be altered. And then a mutable borrowing. A piece of data that is shared and altered by a single variable, but the data is inaccessible to the other variable at that time. Following table references. Okay. Got it. Mutable references or mutable borrow operations are moved while immutable, and shared operations are copied. Yep, that makes sense. All right. The following example shows a shared borrow and a mutable borrow. This into this, and this into this. B can change and read the value of Y in mutable borrows. Yep. Okay. So this is X, which, and then Y. And then A is just a copy of it. Okay. So that would be 10 and 10. Got it. Then they borrow a mutable version. So that's just going to be 13. Yeah, 13 from the beginning. And then we're dereferencing and making it 11. But it'll also be updated here. Cool. Once you have immutable references to variable, dereferencing is a term. Okay, my computer just shut down. Oh, it's back. Okay, don't do that. Not quite sure why it did that. It should just be awake. I'm streaming. Don't go asleep. Anyway, dereferencing. Once you have a mutable reference to a variable, dereferencing is a term used to refer to changing the value of the reference variable using the address stored in the referring variable. Okay, so let operand 1 equals this, and then this equals 2. Shows one mutable borrows the value of operand 2 using mut, and then operand 1 dereferences the value of 2 using the star operator. Point to the value of the mutable borrow variable and can also update that variable value. Okay. So this is 10, then that's 10, then that's 11, and that okay, that'll also be 11. A variable can be updated through if it's a mutable. What's the output of this code? 10 and 12. Why would it ever be 9? In what planet would you... Oh, okay, I see. That was the original value. Precedents and associativities. Oh, this is like PEMDAS, but for Rust. Okay. Yeah, I'm never going to remember that, which is fine. I don't think I even remember what the precedents of like JavaScript operators are off the top of my head. I'm sure that's caught me out before. Left associativity occurs when an expression is evaluated from left to right. An expression such as A, B, C, in this case, would interpret it as A, B, C, where that could be any operator. The operators below can be chained as left associated, as multiplication, division, addition, subtraction, move the pointers, ampersand, k. So, for example, this would be 8 times 9 divided by 7. Okay. That's stuff we've seen before. Then this would be 2, and then 3 divided by 5 is 0, and then the rest. That's a random place to put a random solution button when there's nothing here for solutions, but okay. Why are you making me do math? Okay. 0, 0, be 7, 0, 3 would be 3. Whoa, my math is bad. What did I miss here? Oh, I think I fucked up here. I'm an idiot. Okay. The task to compute this. Important. I love this is what's fun sometimes, right? So we've just been through a whole thing about like precedence, associatability, dereferencing, typecasting, and also just using general like operators, like arithmetic stuff. Then this question says the task is to compute a to the power of 3, well, a plus b to the power of 3, and display it in the console. The following mathematical formula is expanded as a equals a cubed plus b cubed plus 3ab plus a plus b. And then, like, here is the sample input, and this is what you're expected to get, right? So if you do this, this is what you'll get. But they're like the power of x plus y is calculated as data type pow x comma 3. Here is the data type. Here, the data type is a return value of the power function. Nowhere in any of this work has powers or to the power of type come up. I'm not, of course we can work it out, which is fine. Like, it's not a big deal. But, like, if you're a beginner that's never ever touched this before, you're going to be like, how the French toast do I work this out? Like, how do I get this? Because you're not really sure, right? Like, what is this? Like, how do I do that? Right? So now I have to go back and look at arithmetic and be like, cool, we haven't talked about power of anywhere in here. That's all multiplication. So how are you supposed to work that out? And I'm intentionally going to skip and then come back. So I'm going to like press next and see, this is what you wanted me to do. But like, how would you know this? Right? So let me just copy this and take this, go back to this challenge and be like, how am I supposed to know that this is what you're looking for when you didn't explain power of anywhere in this whole thing? So you'd have to look and be like, okay, this is the correct answer, which this part is fine, right? Like, we know that 3 times a times b times a plus b, which would be, if we go here, that would be this part. But if you don't know this part, how would you know how to do that? How would you know that I32 to the power of in a type form? And just throwing it up here like, oh yeah, by the way, the power of is this. Like, no one's going to know that. Unless they're like genuinely somebody who has done any kind of like work before or has, worked with this kind of system before, which I doubt many people have. I don't know how many C or C++ developers are going to Rust. So anyway, test this. This will work. I guess I should print this, huh? Oh, I'm totally wanted to do that. And there we go. All right. Oh, conditional expressions. We love a good conditional expression. If else. If else this. Hey, I love Rust. I just have Rust on my machine again because I got a new PC. Powerful language, but not simple. Yeah, like, my opinion on Rust so far has been, it's fine. Like, I wrote Java for like 7 years, so like some of this is familiar. But like going through this course, which is learn Rust from scratch from these people, it's been pretty good. But like there's been some times where you look at it and you're like you didn't explain how this worked, and then you're just like, answer this question. So they have an if, and the if let, and then match. So we'll learn about if statements first. If expression, if else, if else, if else. Nested ifs, shorthand ifs. All right. If condition, this happens. Cool. If true, statement, else false. If learn language equals Rust, you are learning Rust. Makes sense. Just like most languages. Same with the else keyword. It's just if this is false, and then this could be true. So in this, if this is Rust, else this is whatever. And then if else, if else. If there's multiple conditions to be checked, then if else construct is used. So it's if else if condition else, the same as every other language. So if it's true, it goes right here, then false, and blah 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 blah, and it'll either be true or it'll end up being false, just like this. So if it's Rust, else if it's Java, else print another language. Then you can do nested ifs, which, you know, isn't it fun? Or you can do the conditional and expression. If this condition and this condition is true, do this statement. This is only true if the second if statement is the only thing inside the first if. Okay, there can be so many levels of nesting as you want. So this says if it's Rust and if language 2, you're learning Rust and Java, else you're learning some other languages. Those seem easy and fairly understandable, but shorthand if, which is instead of writing the lengthy if else, we can use shorthand if, which says, oh, okay, it doesn't seem that shorthanded. You're just taking away like a line. Which, you know, like in type, we would do like let something equals blah, true, false. And that would give you the same kind of thing. But okay. Expressions can return a value, unlike statements. Recall the semicolon turns an expression into a statement. It throws away the value and returns a unit instead. Out. So let y bool equals if x equals Rust, true, else false. Okay. Oh, but these. But if you uncomment this and look at it again, it says if it's Rust, true, else false. Got it. What's the output of the following code? Age is 23. If age is greater than or equal to 21, else you are younger than 21. Okay, that one was easy enough. If okay, age 23 and play is true and activity is tennis. So if age, nope, if age is greater than 21, it will be second, right? Bingo. And then finally, they're greater than 21, they playing is true, and it's going to be none of those. Wait, what? Oh, okay, hold on. There's an or statement in here. It's this one. Age is 21, you're allowed to play, and the sport is. Age is greater than 21, you're allowed to play, and the sport is baseball. There you go. Helps if you read the question. What is an if-let expression? If-let is a conditional expression that allows pattern matching. The block of code in the construct execute if the pattern in the condition matches the scrutiny expression. I imagine is what that word is. Hi, English is my first language and I don't speak it. If-let expression begins with an if followed by a let, and then a pattern having values enclosed within round brackets, then an equal to followed by a scrutiny expression. Then there is a block of code enclosed within the braces. Then there is also an optional block after this. Okay. Show me an example. There we go. If let Rust beginner course equals course, print wrote all the values in the pattern be matched with okay. So if this Rust beginner course equals this, what's in here equals this, then we'll do that. Otherwise, we won't. Oh, okay. Wrote first two values in pattern to be matched with a scrutiny expression, and then this. So it's going to say this match. So the last one is C, which would be course. Got it. And then again, if you do just one, it can guess the other two. Cool. In the example below, a defined pattern does not match with the scrutiny expression, so the statement in the else box is executed. Okay. Excuse me. If let Java, yep. Then C equals course. Okay, so none of that's true, so it'll just value unmatched. In this example, the pattern is not defined, rather is replaced with an underscore. In this case, the statement within the if-let block executes. A warning is generated by the compiler because Rust compiler complains that it doesn't make sense to use if-let with an irrefutable pattern. Cool. That's value unmatched. Because beginner is spelt wrong. Those were fairly easy. Match. Match expressions check if the current value corresponds to any. Hide. Gotta love it. And you're in timeout. That was easy. Yeah, I mod my own chat, so carry on. Match uses match keyword. The match expression can be rewritten. Cool. Okay, so define a variable x equals 5. Match x. My dude. This is going to be fun, isn't it? Okay. Carry on. Okay, so define a variable. So I imagine it's going to print Rust. Because this is the same as like a switch case, I guess. Oh yeah, while I'm here, I should probably just hide you too. There we go. Wee! Spam bots everywhere. You should see my Twitter DMs. Okay. So Rust equals Rust. So it will find that. So it will print course name equals Rust. Cool. Some other value, I imagine. And then for this one, matches 2, so that's Python. And then Java. 2 top tier languages. That was easy. Comparisons of different conditional constructs. Use if statement, use match, use let. Okay. Use an if statement if you desire the truthiness of an expression. The single affirmative test. There's no need to evaluate different expressions. It can test expressions based on ranges of values or conditions. It's desired to compare multiple possible conditions of an expression. Its values can belong to the same domain. It can test expressions based on values only, i.e. condition cannot take ranges. And then if there's a pattern in the condition, that it needs to be matched with the scrutiny expression. Got it. Okay. If underscore a modulus by 2 equals 0. Is that something I can actually fucking do? I have no idea. Print number is even. Else, or just print else, print, got to write an exclamation point, and I forgot one of these bad boys. Number is odd. Can I do that? I don't know. We're about to find out. Oh, I can't spell. Heh. I was like, wait, that's right. Okay, cool. Oh, so I just wrote it like a JavaScript. Just realized. So I guess like parentheses don't really matter. Make a calculator. Okay. Two variables named A and B, a character type called operator, which will take plus, minus, divided by, multiplication, or modulus. So it has to be one of these. Okay, so we're going to do match. I've forgotten how to do one already. Char. If it's it would be like plus, right? That's how you do. Fuck me. Yeah, use this little fucking arrow thing. Okay. I'm just super annoyed about like. Yeah. I got it. I'm just more annoyed about the fact that like my chat is currently filled with like 1,000 spam messages that no one else can see except for me. So, that's fun. Um. Mm-mm-mm. Mm-mm-mm. Parent. Wait, I think I don't even. Probably don't. Probably could just do this. What was I supposed to print? Oh, I wasn't paying attention. Oh, got it. Okay. Mm-mm-mm. My face is so itchy. Oh, okay. Good to know. Comma. I actually have no idea if that'll work, but oh, hold up. Did I forget part of this expression? I probably did. Let's open a new tab so that I don't lose my place in a second. Match X. Oh wait. Does the char need to be? What did I mess up here? Oh, do I have to like hard type that probably? Or can it just be this? Oh, okay. I need to actually give it a type. Char has a single quote. Let's just mess around. Fuck around and find out. Okay. Okay, that worked. So then I can just do this and then do. Thanks, chat, for that very useful piece of information. This would be this, or this. And then What happens if the expression doesn't match again? Just print out something else. Right? Go here if the match underscore this doesn't match. Okay. So that would be invalid operator is what you want. Oh, feel like there should be a semicolon here too. That's fun. Attempt to divide by 0. Is that part of this? I didn't read that in the test function. Oh, here we go. The test function given code test supposed to modify it. In the code below, you only written a match construct. First, assume that underscore a is the first number. This is the second number. Please note a and b are both variables, but if you declare a and don't use the code, you'll get a warning. Which is not the case for underscore a. For any integer operator passed, it should print invalid, which it does right now. I imagine now I just need to do the invalid part of which I could probably do an if let. So is this what I want? I'm going to just do an if statement right inside of there probably, huh? Whoa, fuck me, got tabs open now. If b equals 0, this. Wait, I need to do this outside of here. Nope, wait, hold on. Got too many prints here. Delete that one. Say if this happens, then print this. Division by 0 is undefined. And that goes here. Why is there this if b equals 0? Got two of them. Okay. If b equals 0, else print a divided by b. Trying to write this in this tiny ass screen. Okay, I can do that. If b equals this. Test. Okay, what am I missing here? Hey, Scott, what's going on, buddy? Just show me the solution at this point. Yeah, okay, I did that. Bro, that's the same code I got. Okay, let's just do some... Oh, shit. I'm an idiot. Let me just change this to this, and this to this, and then test it. All right, cool. I know how to do things. Was that the last challenge? Yeah, it was. Okay, cool. And on that note, we're going to finish. Thanks, Scott, for showing up at the end. Appreciate it. But we're done. Another stream down. We're done lots of things. Good to see you, buddy. Good to see you. Still a bunch of stuff to go. We'll be live again tomorrow, 3:30 till 4:30-ish. Yeah, and we'll be around for the next one. Thanks for everyone coming out. Really appreciate it. I'll see you